go away. Okay. Well, welcome everybody. And looks like there's quite a few people coming on here. I've got about 5 minutes past the hour, so I'm going to get started. And I would ask that you would hold your questions until the end, and then I'll answer if you have any, and we'll move on from there. But this is going to cover Summit, and would you mind shutting that down? Just kind of cutting in on those. I'm going to cover Summit, utilizing FarmRight and YieldRex, fertility and YieldRex. So incorporating yield within the actual fertility recommendations, which this is going to be, what I'm presenting to you is going to be a synopsis of what I'm going to be presenting next Thursday to the world in a 9:30 and a 1:30 session as well, basically teaching our customers across the globe how to fully utilize yield within the rec equations themselves. Because there's a lot of people that do their equations based off fertility, and we'll talk about that in a moment, but we don't have, but maybe from what I understand, 25 to 35% arguably of good yield data on our server. So there's a lot of yield data that's messing around the world, around the country, and they're not getting the full benefit of utilizing that within the equation. So I'm going to delve right into that, and I'm going to make a bunch of assumptions. And the biggest assumption is that the majority of these people that will be in this session are going to be people that have been utilizing Summit for quite some time. And if everybody would mute your I think I can maybe mute all. I know I could over on the other one. If you guys would, go ahead everybody and mute their speakers just so we don't have any background noise. And I'll move on from there. Okay, so let's talk a moment about yield data and fertility recommendations and how Summit and even Cirrus can be utilized in a more fuller fashion, if you will, for value for customers around the globe. And what I'm going to do is look at a field here, whereas I've got soil test data that I've got in here, and I'm going to concentrate on the phosphorus here. But I've got soil test data on a field that's up in kind of central eastern Illinois, over right near the Indiana border, but not quite into Indiana. But the fertility level ranges from a 7 to a 46 on the FOSS, and basically where I'm going with this is if you come in here to FarmRight, you've got a lot of the land-grant schools that have got the recommendations that you can go out and do recommendations for the P and the K and other variables. The thing is a lot of folks they have yield data, but they haven't quite incorporated the yield data to be able to utilize the yield data as another variable out there across that farm field, such as right here. If we look at this, this is the yield variability ranging from 115 to 320. And I know the colors probably stink, but you get the idea as far as the range here. So every cell now has got a value for the yield variability within that cell. And we also have the p-value in there, as well as all these other variables. And with that being said, let's use yield to actually take off how much actual P was used based upon the past yield production based off the yield monitor data that came in from the yield monitor for the end of that season for our next season here for 2019. So that's the reason why I'm presenting this now, because everybody is getting ready to run, especially in the Midwest, which is where the bulk of our acres come from, getting ready as soon as, of course, the ground right now is wet. You've heard Duncan, you've heard a lot of us talk about that. Our acres are down, but a lot of it has to do with the weather. I've talked to many people in the last few days, and they're stuck. But as soon as it freezes, they'll be running, and as soon as they get that corn or beans off, they're going to be running out there and pulling samples. As soon as they do that, they're going to get the yield data, they'll get the fertility results back from their lab, and then they can go in and utilize what I'm going to jump into right here. So once you get the data back from the lab, so we've got the results, we've got the soil samples pulled, we've got all that information, and we're going to come up here to the season that we're working with. Now, I've got yield data for 16, so I'm going to run back to 16 here. Just play with me here, or just go with me. And I'm going to jump down here to the particular field I'm going to work with. And now, again, the efficiency of our system is to do multiple fields, of course. I'm going to do one just for demonstration. But a lot of people will come in here and place a recommendation. I've assigned several of these to myself, and every one of these have got different agronomic parameters as far as what you would utilize this for. Now, you wouldn't use Oklahoma State on Illinois soils, okay? But my point to you is if you did a PREC through a land-grant school that was just a sufficiency program, it's going to be a different agronomy what's going to be applied on that particular field for the amount of P2O5 that it would call for, based upon if you came up here and chose something that was really, really aggressive, that's using the yield as well as build factors, sufficiency factors, build factors, and maintenance factors. So I'm going to come up here and pick this Crop IMS PREC, which is a very customizable recommendation. We're going to compare the two here and look at what a lot of people will look at right now on like a 2 or 3 or 4 year look back, to look at your base soil test year, adjust where you're at, look at what you have applied, look at what you've taken off, and you kind of got a bank account, so to speak, for the next season for where you're at. So the Oklahoma State one, I'm going to use that because I know it quite well. It's just sufficiency. In other words, it's only going to put out what the actual crop calls for based upon the calibration tables for that university's research. Now, Crop IMS has went in and taken the University of Illinois recommendations, I would assume, because basically this is some GrowMark stuff that they've kind of specialized in, and they have tweaked that, and we're going to look at the different parameters here where you can actually use yield. Yield is not used down here. So you're going to get a totally different recommendation for your P2O5 off of a recommendation parameter that's only doing basically to feed the plant versus feeding the soil up here. So we'll jump into this thing. And I'm going to do it across the entire field. And this is the actual, this is Crop IMS's, which is based out of kind of north central Illinois. So the first thing they ask is, what's the crop? And if this happened to be, if they were going, probably don't go corn for corn, but let's just say, for the sake of argument here, what would the purpose be for dry grain? And by already setting that, there's some parameters that it's got in the background based upon the research, what they've already got in the background as far as the agronomics go, and the algorithm itself. They're asking what you want to build to here for a yield goal for this upcoming year. So you put in whatever that yield goal would be, and then you could do a 2-year build. And I'm not going to assume anything here. If you had a really good year and fertilizer prices are starting to jack up on you, it's really starting to rise, you may want to do a 2-year application, a 2-year build in a 1-year application, because fertilizer prices, you know, you've been reading the news, you've been paying attention, and fertilizer prices are starting to go up. So in other words, you've used this as a logistics tool, as an accounting tool, if you will, within your agronomics, to make a decision that I'm going to buy fertilizer this year. I put down for 2 years ahead in advance at the cheaper price. That's one direction and focus that this could go. And if you did that, you could come in here and say, well, how many applications am I going to do? Do I want to put that all in just a 1-year build, or do I want to do that over the next 2 years as far as the applications go? So I'm just going to do a 1 year here, do it, and we'll just do 1 year period. Then it asks, do you want to use the actual yield? And this is where tying in the yield to the actual fertility side. A good number of our people that I have taught through the years are in a very high level fertility management program. But a growing number of that same number of people are starting to utilize the actual yield data. And we all know yield data is a report card at the end of the year. The issue is getting that yield data in here, and somebody in the model has to make sure that that yield data is valid and make sure that it's clean and that it's not only calibrated coming in off the machine, but it's calculated in the actual values would be out in the real world. Hey, I'm just going to ask everybody one more time, because I can't do it on my end. If you could mute your microphones, because I'm getting some background noise on my end. I appreciate it. So you could say use the actual yield, and that's going to use the yield surface that you create. to actually do a true variable rate or a more true variable rate recommendation per every cell or grid across that field versus just doing it to just a 275 bushel acre yield goal, which you would have on some of the other land grant schools. Now the rec option here on the drop down, and this is a very aggressive recommendation where it's actually using actual yield. You could do a build and maintenance, which would be really aggressive. You could do a maintenance only where you set the soil test optimum cutoff for your P level. You could do a maintenance only or a build only. So they give you 4 options here to be able to go in there and do the actual calculation itself. Now, if you had the money and you wanted to do this for, let's say, the next 4 years, I'm going to do a build and maintenance, which is going to be a really aggressive one compared to just doing what would sustain the plant, which would be a lot less. Because remember, land grant schools, their recommendations are based upon all this research and everything, and they're not trying to sell product. They're trying to sell their science, the specific science that's adapted for the variability in their parts of the world. So you're not going to get land grant schools that's going to create product recs. That's why, and on our side, what we do in FarmRight is only ever create a 100% nutrient rec. So the nutrient rec right now at this point, I haven't told it on the server. Now I've got my default product to use DAP. DAP is 18460, 18% nitrogen, 46% phos, and 0% potassium. So it's going to use the 0.46 to adjust for what it would call for, which is going to call for more of the product because it's not 100%. So my point is that if you didn't know if you were going to have enough DAP on hand, then you may come in here and add a second product, a MAP. MAP is 1152.0. So if you're going to run down on supplies throughout the season on DAP, you could then switch over and use your MAP. What this would do is it allows you to create multiple default product recs and override what your default products are on the desktop summit. And I'm going to make an assumption everybody knows where that's at, but you can only do one default product on the desktop version. Here, we create 2 for you. And a lot of people that suffices for just one, but we've had a lot of people, a growing number of people through the years that wanted to be able to create more than one. Matter of fact, it's endless. You could do as many as you wanted here, and then you could, what a lot of people will do will like favorite their DAP recs so that they're going to use their DAP until it gets to the point where they're running out of actual material in the bins at the cooperative, and they're going to switch over to using MAP. So just some logic, just some philosophy behind the scenes here for what's going on. But the ideal is you're actually using actual yield now to adjust for takeoff of what you actually need for P205 on this field. Now, anything here in the black, of course, is not required. Anything in the red is. But you could come down through here and make this even more aggressive, and you could set your P buildup level at a critical level of 25. You could set your the P custom buildup if you wanted to, all the way down to if you had a starter in the springtime of the season that you were putting down with your actual seed. So you can adjust this out, and that's why I say this recommendation is quite, this recommendation logic, I should say, is very aggressive. One of the more aggressive ones that I teach, simply because they've done a lot of research. These guys have been doing this for a number of years. Now, when I hit next year, we're going to get the Oklahoma State recommendation. And the only thing Oklahoma State calls for, and this would be some of the land grant schools around, if not a good number of them, they're going to call for the crop, which remembers that from the first parameter, and then dry grain. And that's the only thing you're getting. So basically, there's a lookup table in the background that's looking at corn for that part of the world based upon what those number parameters are that's being input into the algorithm to calculate what yield would be, in this case, for just sufficiency. Because all Oklahoma State does, and again, I want to reiterate, you're not going to use Oklahoma State equation logic on a field in Illinois, but it wouldn't matter what lab it would be. Most labs, most university research labs are only going to do sufficiency. You're going to have to get to the custom guys, to the private competitors out in the world, the crop IMSs, the Helenas, and things like this, to get a great agronomy equations that are much more aggressive, like what I showed you there in the previous with crop IMS. So this one doesn't use actual yield. You don't have any other parameters other than basically a lookup table in the background that says for that part of the world, and he chose corn, so it's looking up for corn. Here's the values, here's the range, here's what it's going to do, and that's it. That's all the parameters you get on the input side. So You don't get a lot more input variables to be able to affect here as far as that output when you have something that's very conservative, if you will, or it's certainly not going to be as aggressive as what the previous equation was. I really showed you a very aggressive equation first, and then a very conservative as far as this one here goes. Now, one of your questions might be, why would you want to run that first one versus this one right here? Well, I farmed enough years that, for example, we had an airport lease for a couple of years. And our airport lease, we didn't own it. We only got it for a one-year lease. I was not going to put the money in that piece of property for someone else that I might lose the lease for next year. So I would probably just run a sufficiency, or I didn't know about this information in those years in the 70s and 80s, but if I had, I'd only run sufficiency on those fields that I did not have it on a one-year lease. Land that I would own, I'm going to build up that soil fertility. That's where I'd run that kind of a crop IMS philosophy and build up the soil fertility for maybe in years where, like back in 10, 11, and 12, fertilizer prices just went out the roof, like $900 per DAP a ton. Now it's down to like $425, $550, somewhere in that ballpark. But you do the math on that, and you got 10,000 acres or 3,000 acres of corn and beans and wheat and so on. Your price for your fertilizer inputs alone is just going to go out the roof. So I'm going to run, if I don't own the land, I'm probably going to run one of these that's not nearly as aggressive as what that was on the front side. And the front side one, the crop IMS one, is going to utilize the actual yield within the actual equation itself. So I've already done all of this, and I've already synced it, so I'm going to go into the maps view and show you what the results are as far as that goes. So on our recommendations here, this was actually, let me turn a bunch of this off. This was actually our recommendation for 225, and this was the land grant school one that I ran for University of Illinois. And it shows from 50 to 250 out there across that particular field. Now, of course, the controller is going to see it as that right there. So every cell, as that thing moves across the field based upon whatever the client profile had set that up as, that's what is actually going to be read by the controller. But of course, farmers don't like that, and in your map books, a lot of the map books look like this because it's a pretty map. It's an aesthetically looking map. And of course, it's not calling for any FOSS up here, but then you got lower amounts all the way to where it's putting quite a bit in here. Now, I apologize because I got busy this morning. I didn't run my other rec, but I could run the other rec, and it's going to be much more aggressive on what it's going to call for across the field, because it's also going to take into consideration the actual yield data layer and all those other parameters that I was talking about a moment ago. Whereas this one is going to be somewhat more conservative as far as that amount goes. And, one of the things that we're pushing right now, Graham has talked about it, we talked about it with the ProAgrica acquisition, and that is pushing our Cirrus with an S to the world and getting that into the farmers' hands, and especially into the hands of our agronomists and people that's going to be sitting down with that farmer. So I'm going to switch over here to Cirrus for just a second and talk just a minute. If I can get this to come up. Nobody ever has any technological issues when you're doing something live, do you? I'm on the same Wi-Fi. It worked fine yesterday. I don't know why it's not today. Try this one more time. Well, let me disconnect, or let me try another one of these. Sorry for the problem. Let me try to walk back in here. What I want to show you is how to push that rec as you have utilized the yield and the fertility down to your Cirrus account with an S, and go out to that grower and sit down, and you can adjust that based upon a lot of those parameters I talked about, but you've already encompassed the variability as well as you humanly can on the input side with the yield, the fertility, and any other variables that you may have included within that particular set of parameters for that task. Let's try this one more time. Yeah. Okay, I don't know why it's not sharing across, but basically I'm going to jump in here this way, kill it this way. Two birds with one stone. Just come in here to the maps portion.
I'll flip your screen back.
Thank you. Come to the maps portion, come down to that particular recommendation, turn that on, and come in here to the equation, edit the product rec. And this is basically the same thing you're going to see on your Cirrus screen, only it's in a little different format, and it looks a whole lot prettier, I think, as far as able to understand it. And you get that little chart below. But the idea would be this is running from 50 to 250. That was the input parameters that I had actually set up. But if the farmer looked at this and he says, you know, hey, Bill, I just leased that property and I only have that 1-year lease. I'm not spending that kind of money on that particular field. Then he could adjust that based upon the dollar amount, which I see happening a lot with farmers, and what I hear from the service providers sitting down with their farmers and adjusting it as such before the actual recommendation gets kicked out to the controller. So the point being is that Cirrus can be utilized in a more fuller fashion for the value that can be shown to that grower based on all these input parameters, utilizing yield, utilizing fertility, and utilizing where the markets are for fertilizer, what the weather patterns are like, and all of those things that you can't necessarily collect data always about, but you can utilize your empirical knowledge base to make a decision that's going to be more better informed for that farmer utilizing Cirrus. So, guys and gals, in a nutshell, that's what I'm going to be covering, and especially talking about the yield data, incorporating actual yield into the fertility recommendations and utilizing yield beyond just a pretty yield map. So that kind of can follow is kind of the end of what I was going to cover with everybody. I'll take any questions or comments that anybody might have.
So is IMS private?
Crop IMS is a private company, yes. They're a private organization that's based out of Illinois, and John Douglas works for Crop IMS. He also is under contract for ProAgrica SST, and John will go out and sell his services through Crop IMS, agronomic logic, if you will, their equations, and we get paid on those acres, but we can't handle. There's not enough of us here as account managers, salesmen, and so forth to go out and be able to provide these services agronomically for every farm in the world. That's never been our goal. But our goal is to help those farmers to get to the level where they can use these extra value tools that's available at their hands, but not have to deal directly with them. We call those wholesale accounts. So Crop IMS is a wholesale distributor, if you will, of our information services to farmers around the country. So John will set up and use Crop IMS, PREX, KREX, YieldREX, and so on and the like, and he'll charge like anywhere, he'll get a cut out of it for Crop IMS, but SST does as well. At least ways it's acres that we're making some dollar amount off of in that crop season. Now, the issue with soil fertility alone is that a lot of people utilize our system to go in and create a recommendation on a 4-year build, or a 3-year, or maybe even a 2-year. Predominantly, though, what I've seen has been a 4-year build. So we'll get RECs run in 2016, and they'll apply. So you got 16, 17, 18, and then in 19, they're 16. The rest of 17, 18, and 19, they're not doing any more soil sampling. So we're not getting any other RECs ran through our system. So we get paid in 16, and we're not going to get paid again until now. The point is that they have yield every year. They have yield coming off those custom harvest or off those combines and harvesters every season. And what we try to upsell to people, and what Cirrus can help us to do that with, is to show the farmers that you got enough variability here. Let's adjust this every season. That way we get paid on a per season basis rather than once every 2, 3, or 4 years, and they get the more full capability of what yield can actually help them with for adjusting their fertility amounts across the seasons, across the years, and they see value in it, and we get value out of it. But in the years past, and I think Duncan would certainly agree with me, one of our frustrating things has been just not having something to where we can get a reoccurring charge every season on our farm right services. And with utilizing yield data, we can. But there's a value for us, but at the end of the day, there's a value for that farmer.
Because they're fine-tuning it every year
You
instead
got
of
it.
once every 4.
Yeah, you're shooting more with a rifle than a shotgun,
Right.
so to speak. Yeah.
So in general, if the yield's higher, then they have to use less product on
No, they're going to use more. If the yield is higher, you're going to have more takeoff. So based upon your soil test base year that you started with, what you had actually applied, and what your yield was in the preceding year, you can adjust it out to there and plug those values in, and it's going to call for. It depends, Michael. It just depends. It's not easy to answer it to say yes, it's going to call for more every year. It just depends on a lot of variables.
Right.
But logically, it probably will.
Because if you draw more out because you had good yield, then you need to know, if you do this process, then you can know how much more you need to put in on year 2 and year 3 to make sure you have 4 years of good yield, consistent good yield, by fine-tuning it every year versus having maybe a really good yield first one, then taper it off for 4 years, and then you build it back up.
Right. And that's where you get into this is you get somebody like a John Douglas, or you get somebody that's an agronomist regionally in those areas, and he can sit down and upsell these services using Cirrus and explaining to these guys, here's where the value is by incorporating yield data into this, because we can now incorporate more of the parameters. Statistically speaking, you're trying to look at the full population of every variable that's affecting yield. And in this case, we've only been using fertility, but now we take fertility and pH and cation exchange capacity and organic matter, and now you can plug in yield as well. Yield being the report card at the end of the season. So you're more fine-tuning what you're actually selling as a service to that grower. It's doing him a better job. You're getting paid for that service, but there's value the whole way around. And we can fully automate it. That's what's so cool to me. You can fully automate this. If you know anything about the toolbox years, if you did this, I'll shut up after this about toolbox, but in the toolbox years, and there's a lot of our competition that's still here, they go to one field, they do 37 steps for recommendations, analysis, and all this, and then they move to field 2, same 37 steps. We can blow all that away here with efficiency. We can do 6,000. I did some math one time, and we can do like 6,000 acres with like 29 fields, I think it was, or 30 roughly. 20 variables per field, doing the processing for recommendations, yield processing, all the analytics and everything. It took about 12 to 15 minutes to process that data. And a lot of that, is impacted by the speed you have at your local location, all that for downloads and all that. But the fact of it is that we can blow anybody away.
You're not doing it one by one.
We're not doing it one by one. So efficiency is important for getting on these acres, and especially when we got a year like right now, where it's so wet. These guys are trying to get on that ground as fast as they can. So there's a lot of efficiencies we bring to the market here with our tool set. Good questions. Anybody else? Anybody online?
It's also keep overspending on products year over year.
It goes back to what precision agriculture has morphed into. In the 40s, 50s, 60s, 70s, and 80s, it was maximize inputs to maximize output. If 20 pounds of product will get you to this yield goal, let's double that to try to get the maximum amount of production we can. Now we can sample to identify the variability, to optimize the inputs, to maximize the soil's productivity. And that now is a huge factor in how much you're affecting the bottom line for that grower. And throwing yield into this now even takes it to a different dimension, because now you're adjusting specifically per season rather than just shooting the 275 yield goal or whatever the case may be there.
Makes sense to me.
Okay, one last time. Anybody online have any questions? If not, or if you do, just email me. You guys got my email, but we'll conclude it there, and appreciate everybody coming in. Thank you much, and have a good rest of your week.
Thank you, Bill.
Thanks, Bill.
Thanks, everybody. Yeah, if we could ever